Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on January 30th, 2026, about a week ago. It explains the mechanics behind the Muon optimizer, showing how spectral gradient descent prevents uninformative, high-variance noise from overpowering the signal during training. The paper is titled, Spectral Gradient Descent Mitigates Anisotropy-Driven Misalignment, a case study in phase retrieval. And as we'll see later, the difference in convergence speed compared to standard methods is really impressive. Alright, Figure 1 visualizes exactly why this happens by comparing the learning dynamics of the two methods side by side. The top panel shows spectral gradient descent, or SpecGD. You can see that in the pink shaded region, labeled Stage 1, the blue signal line grows quadratically alongside the orange spike line, meaning the noise doesn't overpower the useful information. In contrast, the bottom panel shows standard gradient descent. Here, the orange spike curve shoots up exponentially and completely dominates the early training, suppressing the blue signal line and forcing the model to waste time before it finally aligns with the target. So, while Figure 1 showed the dynamics over time, Figure 2 maps out the stability landscape. The left heat map represents standard gradient descent. Notice the dark failure region in the top right. As the spike strength on the y-axis increases, you must drastically lower the learning rate to maintain alignment, restricted by that red dashed line which marks the theoretical limit. In contrast, the right heat map for spectral gradient descent is almost entirely yellow. It remains robust to spike strength, maintaining high alignment even at higher learning rates. Wrapping up, the key takeaway is that by ignoring the scale of the gradient, specifically the singular values, spectral gradient descent prevents loud, uninformative noise from drowning out the signal. This geometric update rule offers a solid theoretical basis for the Muon optimizer's recent success. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.